Okay, so the next two sections we are looking at two different laws. First one being today is law of sines. So far, anytime you see sine, cosine, and tangent, you've been told that they can only be used with right triangles. Well, the law of sines and the law of cosines are actually designed for non-right triangles. So anytime you have a triangle that's not a right triangle, you are able to use this, but only, like it says in red, when you have a number across from a number. And I'll explain what that means in a second. So the law of sines is sine of angle A over A equals sine of angle B over B. Now, the reason I have this triangle over here with T, D, and N on it is because in triangles, and this is pretty much universal, if you have a capital letter, which all the angles should be capital letters, straight across from that angle is the lowercase version of that same letter. So this being angle D, across from it would be lowercase d, and across from capital T would be lowercase t. So in this formula over here, you'll notice that A is over A and B is over B. So the angle and the side across from it is going to go together in one fraction. So that's how we set that up. So here's what I mean by a number across from a number. If you look at this triangle, and draw a quick sketch of it in your notes, the number across from a number is right here. So we have an angle, and straight across from it we have a side that also has a number on it. So because of that, we're able to use the law of sines. The law of cosines is used when we don't have that, and we'll learn that in the next section. So the number across from the number is where we start. So what object always comes right after sine, cosine, and tangent? The angle. So 115 will go here, and that's going to go over what? The opposite side. Now we're trying to find x. So what angle should we be using? Yep, the one straight across from it. Now when we have two fractions equal to each other, how do we proceed? Yes, we should cross multiply. So when we do that, we get 15 sine 35 equals x sine 115. How do you get x by itself? By? Now when you type this into your calculator, you do have to be careful to close the parenthesis that they give you around the 35. If you have a calculator where you can't see what you're typing in, this just has the one line. It takes a little bit more thought here, but this is what you would type in if you have a calculator where you can't see what you're typing above your answer. You're going to take 15 times 35 sine, hit equals, and then that divided by 115 sine. So again, this is only if you have a calculator where you can't see what you're typing in. What do we get, or what should everybody get? Anyone not able to get that? Anyone still need this slide? Okay, let's try another one. So do we have a number across from a number? No. Ideas? Yes. The triangle angles always add up to 180, so figure out what that last missing angle is. Yep. So that one is 51. So where are we going to start? Sine what? Over? Over x. Again, we cross multiply. And just like before, we divide by that sign on the right-hand side. Get x by itself. What should everybody get? Make sure you close your parentheses or you will get it wrong. Anyone not able to get that? Okay, I want you to set this one up, but the process is a little bit different. I'm going to give you a head start to see if we can at least get it set up properly. Hopefully all of you got this. So I'm sure you're able to see why it's a little bit different, but the first step is still the same. The cross multiply. What are we going to divide by on both sides here? So now we get sine x by itself. Somebody tell me the decimal we get here. 5 numbers after.
0.89217.
All right, now, what do we do when our variable is in the angle? You know the answer to this already. Sine -1, your inverse trig functions. So you're going to do sine -1 of this answer, and that will give you your angle measure.
63.1.
Any questions on that? So that's everything you need to know as far as law of sines goes. We have one more formula to learn on the last page. And you do not have to memorize these formulas that I'm teaching you. You just have to know when to use them. So when do we use law of sines? Number across from a number. Okay, in the next section we'll learn what to do if you don't have a number across from a number. All right, last formula for today is area of a non-right triangle. So up until now, you've known that area of a triangle is 1/2 base times height. In this case, we don't have the height of the triangle, but we still have a formula that will find the area for us. So A equals 1/2 AB sine C. Now that's just the arbitrary formula. It does not link to the A, B, and C on this picture. So we're going to change it so that it does. So this is the formula that you'll get on the test. We're going to make it match what we have here. So if this is, what object is this? Is it a side, an angle? What is it? Angle. Okay, so we have an angle. The only angle they gave us is the 98, right? So we know that this is going to have sine B at the end. Now looking here, if we have the angle C, what two sides did we use? A and B. So looking at this with sine B, what two sides do you think we're going to use? A and C. So look at this. We're going to use angle B, and then we're going to use A and C. Which one is A? Which one is C? So when you're finding the area of a non-right triangle, you need an angle and you need the sides on either side of it. All we have to do is put those three numbers in here. And just like in geometry, we need 3 lines of work. We need our formula, the numbers you're putting in, and your answer. So our 2 sides we're putting in are 11 and 10. Angle's 98. Third step is your answer. That's the area of that triangle.
Would it be 10, not 11, because it's lowercase a? Oh, never mind.
Okay. Nope. Nope. A and C, it doesn't matter what order you multiply them in. You'll get the same either way. Anyone else? Agree? Disagree? All right. No units, so we don't need units on our answer. Questions on the 2 formulas we learned today? Someone had a great question earlier in a different class and asked if we could use the law of sines on a right triangle, and yes, you can. For right triangles, it's a little bit faster to just use SOHCAHTOA instead of using law of sines, but it does work on right triangles. All right.